Hello, is anyone there in the chat at all? So I'm Sarah, if you didn't watch last week, and we're going to be doing some more maths today and looking at compound interest. So yeah, anyone watching, if you have any questions, just pop them in the chat box as you go along. Oh, hello Clara, nice to meet you. Yeah, if you have any questions or anything you want to ask about any of the topics we go through, just put them over in the chat box down there. Oh, hello. Oh, it's nice to see lots of hellos. Yeah, it's nice to know that there's people on the other end as well. So yeah, it's really nice to meet you all. Are you all new? Did any of you watch last week? Also, just to check you can all actually hear me and you're not just saying hello, yeah? I think there might be a delay as well. So yeah, if you can all hear me, just put a little like Y in the chat box as well, to know that I've got all the audio set up properly. You can hear me, fabulous. Okay, so oh, you're new. Oh, nice to know we've got some new faces here as well. Marcus, you can't hear me, so I think some people can hear, so it might be something with your audio. Make sure it's not accidentally on mute or something. My voice is a little bit low. Okay, let me see if I can fix that. So, can I? Let me see. I'm not the best with all this technology. I'm a little bit of an old lady. It's not very loud. Okay, so give me 1 second. Let me see if it's like in my settings with my microphone turned down. So, okay, 1 second. So I think it should be in here. Is that any better? Or is it the same? Is it in here? Maybe it's in here. Is that any better? Or is that just as bad? Okay, is that any better? It looks like it's going up on the chat bar a bit. Okay, it's good for you, Ella. Okay, hopefully it's good for everyone. Yeah, let me know if it is too quiet, and I will try and fix it. But okay, I'm going to go on with the assumption that it's a lot better. Okay, yeah, I had the wrong thing on the microphone settings. Yeah, if it's really bad, do let me know and I will try and fix things like that. Okay, I'm glad there's lots of things saying much better. Okay, so how do you all feel about things like compound interest? Like, what are you hoping to get out of today? Are you all here because you love maths so much that you can't think of anything better to do on a Monday evening? Or is it because you feel that you have to because you're not happy with the topic? Okay. I think there's a bit of a lag, but I'm assuming you're all here because you absolutely love maths then, and that you can't imagine anything you would rather be doing right now than compound interest. Okay, so what I'm going to do is I'm going to flip to this whiteboard and I put some exam style questions up. Okay, so we've got something like a mixture here of some people who just want a recap and some people who maybe have done it in class before but can't quite recall what it involves, or maybe just haven't covered it yet and you want a bit of a head start. So is this sort of size good? Can you all see this? I'm going to read it out. So here we have Remy invests £1,500 for 3 years in a savings account with 2.7% compound interest per annum. Work out the value of Remy's savings at the end of 3 years. So I'm going to take you through first a long way of doing this and then the shortcut so that the shortcut makes a bit of sense and you understand where it's coming from. Oh, Jude, I see you said it's better but still quiet. I will try and fix it for next week, Jude. If you can, just sort of turn your audio up. It seems to be a bit better for most people, so hopefully it's listenable. Okay, so here, this is actually very similar to what we did last week for anyone who was here. We are going to go through it from scratch anyway. But this just starts off like a normal percentage question. And you first want to ask yourself, is it a percentage increase or decrease? And the clue for these questions is this word here, interest. So does anyone know, if you've got interest on your money or on anything, is that a percentage increase or decrease? And just maybe put in the chat what you think. I'll give you a couple of seconds because I think there's a little bit of a delay. So I'm going to go ahead and say it's an increase. Oh, fab. Yeah, thanks, Ciara. That's great. Yeah, exactly. You're all completely correct. Increase. So before you go in and dive in with that 2.7%, we want to make sure that we add that as a decimal onto 1. And we're adding it because it's an increase, not taking it away. So the first thing we're going to do here, like any percentage question, once we've figured out if it's increase or decrease, we're going to take 1. Oh, why is it red? Let's go for a easier color in the eyes. Okay, let's go for 1. And what we're going to do is we're going to add on 2.7% as a decimal. So how do we turn 2.7 into a decimal? Does anyone know? So what we're going to do is we're going to divide by 100. So for any percent, that per in maths, per is just divide, cent is 100. So divide by 100 to get what you want to have there as a decimal. So divide by 100. And then this is going perfect, Ciara, yeah. Sorry, there's a delay. So if you type in chat, but I carry on as if you haven't, that's why. So this is going to be when you add this on, 1.027. So when you do this, one common mistake is because you can kind of rush to this by doing 1 point and then your decimal here, your percentage here. Just make sure if you do this that your first number after the decimal are the tens and the number after are other ones. So after this, we need a 0 for where the tens are because it's 2.7, not 27%. I see, Luca, you completely correct yourself there. But for anyone who's not sure, because I do see that come up quite a bit. So we've started. We've got to what we need to multiply to increase it by 2.7%. Marcos, where do we get the 1 from? So I'm going to just do this on the side really quickly. What we're saying is if we're starting off with 100%, oops, and we're increasing it by 2.7%, so we're adding 2.7%, then what we are actually wanting to find out is 102.7%. And that's kind of where the 1 comes from over here. So that 1 is actually from the 100%, but divided by 100 to get a bit of a shortcut there, because this is going to be 102.7 over 100, which gets us to this 1.027. So this is like a little bit of a shortcut in a way. Yeah. Okay. So I see some people have rushed to the answer. I'm going to explain it like step by step and then show you the method for putting it all together in one, because that's the method we'll use afterwards. So if we've got compound interest, and that's the keyword compound, what that means is that every year we increase whatever value we have at the end of that year by that percentage. So for example, at the end of year 1, we're going to have our starting value, which was 1,500, and we're going to times that by 1.027 to increase it by 2.7%. No worries, Marcus, I'm glad that was helpful. Yeah, and then this is going to equal, I did do this earlier, 1540.5. And then year 2, our new starting value is a 1540.5. And again, we increase that by 1.027, which gives us 1582.09. And then finally in year 3, our new starting value is 1582.09 by 1.027, and we get 1624.81. And this is a perfectly valid method for working this out. Erin, you can see you are completely correct. Well done. I'm sure there are other people as well. So all of you, well done who got that answer. But we can squish this method all into one calculation. So if we have a look at what we've really done here, is we have taken our starting value, which was 1500. We timed it by 1.027. We took that value, times it by another 1.027, took that value and times it by another 1.027. So in total, we've times it by 1.027 3 times. And remember, like, if we have a number times by itself a number of times, we just put it to the power of however many times we've multiplied it. So we can squish this. So I'm going to do this in different color just to show like this is the way that I would recommend it. So we'd have our starting value, in this case 1,500, and that's always what we want to start with over here. We're going to times that by our whatever we need to times to get the percent or increase or decrease. So in this case, the 1.027. So for the percent increase in this example. And then we're going to put it to the power of how many years we have that interest for. So in this case, 3, because it's for 3 years. So number of years. And that's really the method. Would this be on a calculator or non-calculator paper? Compound interest is usually on calculator because it's quite hard to do the powers in your head. Like to do 1.027 cubed is quite difficult. So yeah, this would be a calculator question. Generally most syllabuses, most topics could be on either. But yes, some are better suited for one paper or the other. So yeah, and then this would give you your answer that we already said. So 1624.81 with a little pound sign there. So this is the method. This is what you want to be doing for these questions. Okay, so let's have a look at a different example. And the next one that I have here is like a really common style of exam question. So we've got here, Fiona wants to invest £7,500 in a savings account for 5 years. I'm not too sure why the pound sign is so tiny, but oh well. Her bank offers 2 different savings accounts, and we've got 2 options here. So on the left-hand side, we have a fixed saver, and on the right-hand side, we have compound saver. Which count should Fiona choose? And of course, she wants to be getting back the biggest sum of money at the end of those 5 years. So here we have two different types of interest. And I wanted to do this type of question to show you that it's not always a matter of multiplying by that percentage increase or decrease to the power of that number of years. We only do that for the compound interest. Fixed interest or simple interest is different. So we're going to do both examples so you can see what I mean by them being different. Like I said, any questions, just stick it in the chat box if anything doesn't make sense. But I'm going to split this into two, and this is how I would do an exam question. So, and on the left side, I'm going to calculate what I do for the fixed, and on the right-hand side for the compound. So first of all, because we've just done it, let's do the compound interest one first. So we're going to use that method from before. If you all want to have a go at doing this, see what you get, compare it to my answer at the end, please do. I think it's great practice. So our starting value, 7,500. So we're going to do 7,500. And then we want to figure out what we're doing each year. So over here it tells us it's 3% increase for the first year. So that 3% increase is going to be 1 plus 3 over 100, which is going to be 1.03. And then that's year 1. And then for years 2 and 3, it then decreases to 1.9%. So we're going to do the same thing, and then we times it by 1.09. Oh, what am I saying? 1.019 for 2 years, so it goes to the power of 2. And we can put this in our calculator, and what you should get is, where did I put it? I'm going to put it in my calculator once more. Everyone put it in your calculator because I don't know, I've got myself muddled. So by 1.03 by 1.019 squared, so that should give you 8,000, oops, where'd it go? £8,021.34. Yeah. Is everyone happy with that? Do you all agree with me? You are completely right. That's why I got myself muddled, isn't it? I was thinking 3 years like the last question. Thank you for that. So yeah, we're going to change this instead to 4. Thank you, Luca. So yeah, that makes a lot more sense. So that's the power of 4, which gets us to, instead of this, 8,329 pounds and 5 pence. Yeah. Okay, so that's how much it is at the end of 5 years for the compound saver. And now let's go to the other one, so the fixed saver, which is the other type of interest that you will see. So simple interest or fixed interest, it's different in that you work out what the percentage is that you're adding on, and then you add that same amount every single year. So the amount just depends on the interest from year 1. It doesn't matter what value we're starting from in the subsequent years. Where did the 1.03 come from? So I'll do it up here. So first year is 3% interest. So we do our 1 plus 3 over 100. And that's where you get your 1.03 for year 1. And then years 2 and 3, and 4 and 5. I need to get 3 out of my head. So for years 2, 3, 4, and 5, it's 1 plus 1.9 over 100, which is where that 1.019 comes from. Okay, so let's go over to the fixed saver. I see some people have worked through already, so we'll catch up with you now. So what we're going to do here, first of all, we want to figure out how much we're going to add on. So I'm not going to just increase the year 1 by that percent and times by 1.0234 because I want to actually work out what the percentage increase is so that I can still add that on in the next years. So what I'm going to start with for simple interest is take my starting value, so 7,500, and find 2.34% of it. So I'm going to times it by 2.34 over 100. So just finding the percentage, not the percentage increase. When you do this, you should get £175.50. So every single year, we are going to add £175.50 on. So for this one, what we're going to do is we're going to times it by 5 first, because there's 5 years. So we're adding it on 5 times. So 175.5 times 5, which gives you £877.50. And then we just add this on to where we started from. So we do 7500 plus 877.5. I'll put the 0 on because we're talking money. And yeah, and this will give you your final answer, which will be £8,377.50. So everyone who said the fixed saver is what she should choose, you're completely correct. In an exam, I just write a little sentence saying something like 8377, oops, not 8, pounds 50 is bigger than 8,329 pounds 5. So Fiona should choose the the fixed saver. And yeah, that's how we'd go about answering this question. So we have a little bit of time. So I have one more question to go through. Does anyone have any questions about anything we've been through already? Like anything you'd like to ask? I'm aware there is a bit of a delay, so I will just wait a little bit. But yeah, if you're all happy, just put in the chat that, no, this is good, I've got it. I could do this with any question now. Okay, I'm going to carry on, but I will keep my eye out. So if there's any questions, I will keep my eye out if they haven't come through. So what we'll do really quickly, I don't think we'll have time to go through the whole of this question. Is this the hardest question to get? I'd actually say it's quite a standard question, actually, Daniela. So it's one that comes up a lot with different numbers in there, of course. So it's worth spending a bit of time practicing that style of question until you're happy with it. Because although, yeah, it may look quite tricky because there's lots of parts to it, if you do it a lot and it comes up and you've practiced it, it suddenly becomes a lot easier for you. So yeah, it would be quite a few marks because there's multiple steps. Do we have to multiply the percent? Actually, let's go through and answer your questions so that we finish understanding it rather than more confused. So do we have to multiply the percentage by 100 for all questions like this? So do you mean divide by 100 maybe? Because it's kind of what we're doing. For these ones, we always divide a percentage by 100 to find out what we need to multiply and use in our equation. Because when we see the word, let me go back. When you see a percentage, it's kind of like a nice way, or a nice looking way of writing out a fraction over 100. That's that percent. So whenever we say something like 73%, if we want to use that in a question, that's 73 per turns into a division and cent turns into 100. So yeah, in that sense, you always want to divide by 100 if you want to use it when you're working out anything in a question. Yeah, divide. Yeah, no, I figured you meant divide, but you're completely correct. So yeah, that's that one. So the only other thing that to be aware of with these questions, and I'm really quickly going to touch on it in the next question. Oops, where did it go? There it is. Okay, so for this one here, so this is where it becomes a bit different, and you've got to really be careful with reading the question. Is here they're talking about a house depreciating in value. So for simple interest, is it not the original amount times a multiplier? So you start from the original amount and then you're adding on the percentage of that original amount for every year you are in that savings period. So that multiplier is multiplied by the percentage of the original, not just the total original. And then you add on the increase at the end. So yeah, so just really quickly here, like for a note on this question, is, so this one here, he's bought a house, it's £175,000 in 2018. After 1 year, it's increased by 3.5%, but then the following 2 years, it's decreased by 1.5%. This is probably like the harder question that you'll see on this, where they're mixing lots of different ideas together. And so we have two things going on. At first, it increases by this percent and then it decreases. So for that period of time where we're increasing by 3.5%, we're going to do the same as before. It's an increase, so we do 1 plus 3.5 over 100. So it'll be 1.035. In other words, 1 plus for the increase, 3.5 over 100. For the other section of time though, we are going to decrease it. So for this question, you would do a decrease by 1.5%. And in this case, you would do 1 minus 1.5 over 100 because it's a decrease, which will be 0.985 that you'll be multiplying by. So I'm not going to do this because we don't really have time, but this is something to be aware of when you have these questions. You always have to check, is it increasing or decreasing by that percentage? And that's going to change what you're multiplying by over here. So yeah, I hope you all found that useful. I'll just change back over here. Oops. Yeah, there we go. Yeah, I hope you all found that useful. And I hope you could all actually hear me during that too. We'll be doing this every Monday at 5 with a different topic each week. So feel free to pop back next week as well. It's always nice to see a recognizable name in the chat. And yeah, I will see you then. Bye.